we can go up here into y equals, and if we have stuff on both sides of the equation, we could just graph the left part as y1 and the right part as y2, and then do what with the graphs? Remember, if I'm trying to find the places where 2x squared minus 2x plus 15 equals x squared plus 8x. We did something like this with absolute value functions, but it's been a while. But we're going to start using more graphing calculator, using technology. There'll be two parts to every test from this point forward, a technology part and then just a non-calculator part. So one way we can do it is we could just graph those two different functions and look for the intersections, because isn't that really what we're asking here? We want to know when is this function, call it f of x or y1 or something, equal to this function, meaning when do they cross, right? So if we just look for the intersections, it's going to tell us the x values where that happens. So let's go ahead and do the left one as y1. So 2x squared minus 2x plus 15. Okay, and then we'll go down and do y2 will be x squared plus 8x. Oops. And what could happen here, though, is that it may not be a convenient graph. If we hit zoom fit, or sorry, zoom standard, zoom 6, if we're lucky, they'll show up on that screen. And there's one of them, but it looks like the other one did not, right? So what do we do? What do we need to do to our window? Say it again. We need to make it larger. Yeah. Yeah. Okay. So let's go to window, and let's go from, how about from negative 20 to positive 20. And this is just a matter now of just kind of seeing what happens. So I'm going to go ahead and hit zoom fit, which is zoom 0, right? So now it's going to fit the y values to that, so it's going to stretch the window out probably a lot. Okay, and it looks like we're getting some intersections kind of down there, doesn't it? Everybody agree? Looks like it's crossing like right about there and right about there. If I want to get in a little closer, there's another zoom feature I'll show you. You can do zoom box. If you do zoom box, which is zoom 1, then what happens is you get to define a box. So I'm going to go all the way down here, and I'm going to choose the lower left corner of my box and hit enter. And then it's going to anchor the lower left corner. And now when I scoot to the right and up, look what it does. It's going to drag out a box that's going to become my new screen. See how that works? So I'm just going to, that looks probably pretty good right there. Okay, so I'll just go enter. Now it resizes the window, and I can see the intersections pretty well. Got it? Okay, so where do you suppose I go to find the actual intersections? Where do I always go if I've got a question I'm going to answer with a graph? Right, second calc. So are you guys, Jill, are you getting all this? Because you're going to have an assignment on this.
Yes.
Okay. So which one am I going to pick? Number 5, yeah, intersect. And then all it wants is it wants to know, remember this thing, we went through this, first curve is the blue curve, which is y1. Notice it actually gives you at the upper left of the screen, it says, this is what we're assuming the first curve is. It's y1 equals blah, blah, blah. Yeah, that's one of them. So I hit enter to confirm that. Now the cursor's on the other function. Is y2 equals blah, 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 the second curve? Yes, it is. If I've only got 2 of them on there, I don't even have to think about it. I just hit enter, enter, right? But what if I have 5 or 6? Then I've got to carefully choose the 2 I want to intersect. Now it wants a guess. So because there are 2 of them, we just need to either trace, or I could even pick a value, but I can't even really see what I don't really know what the scale is on there. So I'm just going to trace down close to this intersection and hit enter. and it's going to tell me the exact value, decimal value, right? This isn't going to, I shouldn't say exact because it's not exact. It is a decimal approximation. But on all of these questions, you're going to be asked to provide decimal approximations, okay? So rounded to the nearest hundredth, so 2 places. So one of our answers then is going to be, what does that round to? 2 decimal places. 84, right? Because it's 1.83, and then the next digit is a 7, which pushes the 3 up to a 4, right? So 1.84, put a comma. Now we'll go find the other one, so I just go second, calc, intersect, right? Enter, enter to confirm the 2 curves, and now I just have to move the cursor up here. Well, it looks like we're going by ones at the bottom, doesn't it? Right, because it was 1.84. So wouldn't you say that's about, let's see, 1, 2, 3, 4, 5, 6, 7, 8-ish? So I'm just going to type in 8, and it'll know that I mean x equals 8 for my guess, and it moves us up to this one, right? I could have just traced up there and hit enter also for my guess. So then we get 8.16 for our other. Everybody agree? Okay, and we got it. All right, so another way we could do this, though, there's an alternate way. We could always take our original equation and we could put it in standard form also, right? Everybody agree? I don't think there's that much of a difference. They're both going to work fine. But if we want to use the non-graphical way of using technology to solve this, it needs to be in standard form. Okay, so what would we do to put this in standard form?
Move the x's to one side.
Yeah, move everything to the left this time, right? Does that make sense? Where we'll get a positive number of x squareds. So if we do that, we're going to get what? X squared minus 10x, good, plus 15 equals 0. And so we could go back and do a similar thing graphically. We could just go up to y1. Let's go ahead and erase y2. And we'll just go up to y1 and change those coefficients. So that goes away. This, I'll insert a 0. So we just get that. Now if I graph this, I'm going to go ahead and go zoom 6, zoom standard, and we'll just see what we get. And that time it worked fine on zoom standard. Because what are we looking for here? If we're trying to find the solutions to a quadratic equation in standard form, where are they going to be on the graph? What's this really asking? This is my function, right? So it's like saying if this is f of x, let's say this is f of x. Oops. If this whole thing is f of x, we're just asking when f of x is 0. Well, what does f of x stand for, of course? Which variable? Y. So we want to know when y is 0, and where is that on our graph? The intercepts, yeah. So these are just the x-intercepts or the zeros of the function, right? And so now we can go into our calculator and we can say, same as before, we'll just go, let me make this bigger so you can see it a little better. How about it? So now we can just go second calc, which one? No, not this time. We're fine. 0. Yes, we want second calc 2. And it's going to ask for different stuff. It wants a left boundary for one of the zeros. Well, let's take this one down here. A left boundary would be someplace to the left of where we can see that roughly that intercept is. It looks like it's about 2, doesn't it? Right? So we could either trace, so I'll do one of them with tracing. We could either just trace over someplace to the left of that and hit enter. Now it wants a right boundary. Look what it does on the new calculators. I think with the new operating system, I think on every calculator. It puts up a little dashed vertical line saying, okay, that's going to be the left boundary of where we're going to let the calculator search. Now the right boundary means we have to go over to the right past the 0 somewhere and hit enter. And now it's just going to look between those two. This next one, I don't really understand why you have to do this. This seems like on the TI-89s you don't have to. But it wants a guess. You can just pick any point in between those two boundaries and hit enter. And it's going to give you, well, there's the number we had from before, right? 1.84. Okay. And then we could do the same thing. I can go second, calc, 0. And for my boundaries, I'm just going to use a number this time. It looks like that's 2, 3, 4, 5, 6, 7. It's a little past 8, isn't it? So I could type in 8 and hit enter. And then maybe 9 and hit enter. Then for my guess, I could even type just like 8.5, some point that's somewhere in between, and it gives me the other point. Okay, make sense? So those are the two graphical ways. They're virtually the same thing. What about non-graphical ways? Okay, there's also a way we can do this non-graphically. So if we go back to our standard form version of this equation, there's a program that if you don't have, you need to get. If you go to apps, I think it comes now on with the new operating system, it's preloaded, but it's called Polysmlt 2. So it's Polynomial Simultaneous Equation Solver 2. So I'm gonna go to that app, so number 8. And it gives me a menu of all kinds of stuff I can do. All I really want here is polynomial root finder, okay? So I'm just gonna choose one. And then it gives me this screen. Now this is going to be really useful next chapter when we're talking about solving, but working with polynomials. But for now, it's still useful, but just maybe not quite as useful. Let me do it with my pen. Oh, there it is. So if you look up here, the order of the polynomial, we haven't really talked about this yet, but that just means what's the biggest power of x. Well, for a quadratic, it's going to be 2. And the default is probably going to be 2 on your calculator because that's most commonly what we would do. But what's really nice about this one is, look at what it'll give us. We can choose the next row down. We can choose to get real solutions, or we could get imaginary solutions in standard form, so a plus bi. That's really helpful. Then you can also get imaginary solutions in polar form, but we haven't talked about that yet. In fact, we won't talk about that in Algebra 2. You can also, down the third line, you can have it either set it on auto or shift it over to decimal, right? So for us, we'd go ahead and put it on decimal, right? Because we're just asking for decimal solutions. So I'm going to go down and change that row to decimal. And then you can control other things. Do you want it normal, scientific notation? Just normal, right? And float, we'll just let it be on float. Although we could, if we wanted to, we could even put the number of decimal places to 2 and it would round for us. I mean, not that that's a big deal. Yes, sir?
Is auto the same as fraction?
Auto will make it a fraction or a square root if it can. Yeah, it'll try to give you an exact answer.
I don't have auto, I just got a decimal fraction.
Oh, okay. Huh. It's, which calculator do you have? Okay, it might be an operating system thing, and it might be a calculator thing. I bet it's an operating system thing. There might be an upgrade for you to do on the operating system. But either way, but if it says fraction and decimal, then that's fine. I mean, it's just gonna, you would probably choose in this case. Either way, you're gonna choose decimal, right? I'm gonna go ahead and go down, and I'll just make the float go out to 2 places, just so it will round for us. And then all I have to do, now I'm done. I got it all set up. And then once you've set it up, you don't have to repeat that. It's just going to keep those settings. Then you go down to next, which is, these are the soft buttons at the bottom, so they're the function buttons. So I would just hit that guy. And now it just wants me to type in the coefficients. Well, what are they for me? So A1, which is currently highlighted, is 1, right? Scoot over to the right. What's A2, or what's B going to be? Gives it to me in ax squared plus bx plus c form. That's new also. Didn't used to do that. That's kind of nice. What do I put in for B? Minus 10. Minus 10. Yours might look slightly different from this. Does yours say A2, A1, A0? Okay, that's fine. It means the same thing though, doesn't it? You can just look at the picture up there. And yours will probably say A2x squared, A1x, A0, A sub 0. Is that right? Okay, if you don't have the app, then you probably need to go download it. Just go to TI and download it onto your calculator. And then I'll just finish this up though real quick. So -10, and then my last one's gonna be 15. Raise your hand if you do have the app on your calculator. Oh, wow, not many. Okay.
Raise your hand if you brought your calculator today.
Wait,
Okay.
I'm just.
Not me.
The other thing we can do, when we go to the lab, I can just copy it over to your calculators too. Maybe we just do that while we're in the
How do you
lab.
enter the -10 again?
You go back to, on yours it's probably a sub 1. You just space down and go a sub 1 and you just type in a -10. Is that right? Okay, so last thing, this one, I'll tell you what, I'm taping this, so you might have to go back and just look at this video if you don't have it on there right now. And of course, I'll help you in the lab as well. Last step, when I get these all in there, where do you think I go? Which function button am I going to push? Solve. If I push solve, look what it does. It gives me the solutions right there. Okay. And what's really cool about this is, and you'll appreciate later, is I could set it up to give me imaginary solutions or complex solutions with imaginary parts, which is huge. That's really, really helpful. Okay. Saves you a lot of time. So I'm going to ask you to do maybe a little bit of each on this quick assignment, just to get a little practice using graphic calculators. I want you to have to like find stuff in the window and just get a little practice with that. Okay. That's it. Let's go to lab. 205.